So once again, we have some quick column statistics for our assessment, where you see the min, the max, and the average. I'm going to just grab a quick copy of this record, and now I'm going to go ahead and run the item analysis. This will give us a chance to see where the greatest challenges were for our students. But what you saw just a moment ago was the reconciliation. So the reconciliation is already posted, and it's ready for you to go ahead. We want you to finish the reconciliation and the retakes for Module 1 and Module 2 by 3 p.m. on Friday. And then we want to go ahead and do any final review and then post the exam so that you can have over the weekend and until Monday 3 p.m. to complete the exam. So that's the game plan. There were 18 questions. 3 were considered easy, 14 were considered medium, and 1 was considered hard. The discrimination statistics don't account for mastery learning, so if it says poor or cannot calculate, it means that everybody knew something so well they all answered the same, or everybody got it wrong. But basically, what we're going to do is sort by average score from highest to lowest and have a look starting at the bottom. So these were the items that posed the greatest challenge for students in the class. We'll review all the way up until these questions. And we'll also do the multiple answer here because that's a half-point question, and the ordering. So this multi-answer and this ordering. So in terms of matching, basically matched the following terms or acronyms with their respective associations or uses. So MSC, that's a managed service account. Actually, I may go ahead and post some credit for this. That's supposed to be MSA for managed service account. Let's open up our study guide real quick. Yeah, okay, that was my mistake. It should have read MSA instead of MSC. So an MSA is a managed service account. I'll go ahead and amend the score for that one item. But basically, a securing hashing function will help you authenticate a message that it hasn't been changed. Whenever you hash something, if the hash changes, the message is changed. If you hash a message and it hasn't changed, then the message has not been changed. So you get message authentication without confidentiality. It's not encrypted. So this is the answer choice that was supposed to match with secure hashing function. For this MSA, it would say authenticates specific rights for an active program or service. If it's a managed service account, it authenticates the rights for a service account. Once again, we have a variety of account types. When you're looking at IAM, you have 2 sides of the house, the identity side of the house and the account side of the house. Security account management is a component of the accounts side, and there's three different types of accounts that we talked about: user accounts, system accounts, and service accounts. And in class we did break out some things about standard service accounts, and then you have this thing called a managed service account. So when a managed service account is used, it's basically authenticating the rights assigned for that particular service. So are there any questions about this one clarification right here? Again, my apologies, that doesn't say an A. We'll probably just give everybody credit for this item. Digital envelope. Digital envelope includes a key to decrypt the message. So in other words, it not only authenticates the message, but there's also confidentiality. So if you have a signed message that's been hashed to provide authentication for who sent it and whether the message changed, but there's also an encryption key, then you have the components of a digital envelope, which means you have message authentication with confidentiality. A certificate authority is the root of trusted public key infrastructure. So this term PKI is another way of talking about certificates. When you have public key infrastructure, you're talking about a very large enterprise database that stores and distributes certificates, and the root of that public key infrastructure is a special server that runs certificate software. It's called a certificate authority. You either have a root CA, a root certificate authority, or you have an enterprise CA. Does anyone have any questions about these four terms and the answers that are supposed to match?
Yeah, I just want to double check again. Digital envelope, was my understanding initially that a digital envelope did not really have any confidentiality. You're saying it does.
Yes. If you send a message as a digital envelope, it includes the key. And the reason it includes the key is so that you can decrypt the message.
Okay. Okay, sure thing.
So.
Oh, I confused it with digital signature. Okay, yeah, I followed it up. I confused it with digital signature.
Right. The signature, so somebody can sign a message using their private key. So David has a private key. And when David has public-private key pairs, because he enjoys using certificates for encryption, basically you have a private key that you store, or there's a special copy of it that's stored in the root CA. So the certificate authority manages those generally. It's a centralized way to manage those. But you sign your message using your private key. When people want to see if David sent it, they use your public key, which is freely distributed. And if they can get a match, if they take your signed message and they run it across they process it with your public key, it'll match and it'll say, yeah, this is David. This was signed by his private key, and David's the only one that has the private key. And the certificate authority, which is the central repository or database for those private keys. And it's super secret, super encrypted, and super special. And we take it offline, and we turn it off, and we store it in a vault, a physical vault. And so everybody's private keys are stored in a very secure manner. But we float the, you know, on your system, you have a copy of your private key when you sign stuff. If you have that envelope, basically, you're adding something to it. So, yeah, if we talk about when the encrypted message is sent, see that the message is encrypted. It includes the encrypted symmetric key. So one of the tricks for encryption that's always been a bit of a conundrum is this idea that the best encryption happens with a symmetric key. That's a one key encryption method. That's not as secure because you have to have both copies of the key on the encryption side and the decryption side. And if anybody gets a copy of the key, they can read anything. And so the problem is that you have to protect the symmetric key. When you're sending a digital envelope, there's a copy of the encryption key included. But you get to use that on the other end because you decrypt the symmetric key with your complementary private public key pair. So let's give another example. David, you encrypt a message and you send it to me, okay? And you sign the message and you encrypt the message with your private key. Are you with me so far? Well, actually, no.
Yes.
Actually, no, you don't. You sign the message with your private key, then you hash the message so that basically it doesn't. You have a way to check to see if somebody's modified the message. Then you encrypt the message with a randomly generated symmetric key. And then when you create the digital envelope to send it to me, you encrypt the symmetric key you use to encrypt the message with your private key. So now there's a copy of an encrypted key that's also used to encrypt or decrypt, right? So when it gets to the other side, I take your public key, I decrypt the symmetric key so I can use it. Then I decrypt the message. So it is a little convoluted. It is a little hard to understand. But the important thing to understand is that a digital envelope not only includes a signature and a hash to ensure that everything that you need to prove the identity of the sender, the authenticity of the message, it has not changed, and to keep it confidential so nobody except its intended recipients can read it. That's what the encryption does. It scrambles the message, right? So a digital envelope provides all three elements: confidentiality, integrity, and assurance. Or, yeah. Any questions? Now, if I'm sending you the message, I'm using my private key and you're using my public key to work the other side of it, right? So if I'm sending David a message back, he's got the private key, I've got the public key. It depends on who's sending and receiving, but basically these scenarios can change. The important point to remember is that people who receive messages from others have the public key. And then when you go ahead and send your key back, when you send your message back, you have my copy of my public key. Does that make sense? I have your public key, you have my public key. So when I'm sending a message back to you, I'm using my private key. And you're using my public key to do the reverse on the other end. Does that make sense?
Yes.
The main thing is it can get very, very complex, especially with a lot of diagrams. But the main thing to remember is who possesses the private key? Just the owner. Who has a copy of the public key? Everybody else. right? Okay. Any questions before we go on? Privileged account management is a component of identity specifically. So the statement reads, privileged account management is a component of identity, not identity account management as a whole, just identity. Specifically, it is a security factor used for authentication. We get back to this diagram at the top. All right, so when we're talking about identity, we're talking about this side. When we're talking about PAM, we're talking about that side. Security factors are used to authenticate someone's identity. That's over here. Where do you find PAM? Over here on the account side. When we say factors, we're talking about identity. When we say principles, we're talking about accounts and groups. So PAM is a component, it's a security principle that's a part of accounts management. It's not a part of the identity component. The identity component is on this side. So that question intended for you to look at this diagram and go, oh, that's on this side. That doesn't, identity is over here. But let's read the question again. It says, privileged account management is a component of identity. Specifically, it is a security factor used for authentication. And that's false because PAM is, it is not a factor, it is a security principle. And it has to do with groups, group membership. Does that make sense? Are there any questions?
Yes.
Okay. Okay, everybody's quiet. And I am just a little worried about that, but let's keep going. Certificate components. Select the option below that reflects the components of a properly signed certificate. So this was a multiple choice question. Said the option below that reflects the components of a properly signed certificate. There's actually a slide that we reviewed in class. It shows the certificate, and it shows that there's the sender's public key, the digital signature of the CA, and there's contact information of the sender and the CA. So there's actually 4 pieces that are part of a properly signed certificate. Before it's properly signed, it doesn't have information from the CA and it's not signed. So when you're ready to send somebody your certificate, basically the CA has to do a little more to turn it into a properly signed certificate. The rest of the answers here are bogus. This is the one answer that caused the most confusion. The public key of the sender and the CA, including contact information for both. No. A digital certificate doesn't include the public key of the CA. You already have it. Let me show you. Does everybody see this?
Yes.
Okay. Believe it or not, inside your computer, there is a store for certificates. And when you run Microsoft Update, the certificate authorities' public certificates are distributed worldwide. So Amazon updates theirs, Network Solution updates theirs, Google updates theirs, Microsoft updates theirs. All of the certificate authorities put out their certificates. And when you do Microsoft Windows updates this way, those are pushed out to you and they're stored. You already have those on your system. When someone's digital certificate is signed, the private certificate, the private key of the certificate authority is used to sign your key. It's used to sign your certificate. And when you receive it, it's validated by the store you already have built into your system. So what are we saying? If somebody slips a bad certificate in from a root authority, everybody who connects, let's use Google as an example. If somebody infiltrates Google's certificate authority and they corrupt the certificate and they put a bogus certificate in there, then you can create fake websites that look like Google. And when people try to validate their connection and their session security and all sorts of things, it's going to authenticate back to someone else's certificate, which is why you hide it after it's created and set up. You take it offline, you power it off, you put it in a vault. You at least leave it air gapped. You might leave it running, but you don't connect it to anything or anyone. When we say air gapped, we mean there's no wireless connection, there's no network cable connection. It's a completely isolated machine. Anyway, does anyone have any questions about this item? So where did we get the information for this question? It's in the Encryption Essentials toward the end. Where is it? There it is. Okay. So Bob's information, the certificate authority's information, and Bob's key. And that's signed by the CA. So the CA takes a private key, signs Bob's public key. That's what creates the link for trust. So you trust Google's, Amazon's, Microsoft's, Apple's certificate authority. And if Bob is squared away in his account with Microsoft, Apple, Google, Amazon, and so on, then they sign his public key, and then that's used for all sorts of things. That's what a signed certificate actually is. So it is someone's public key, the CA information, the owner's information, and there's a signature from a trusted authority that validates it. And without that signature, it's an unsigned certificate. You might see warnings on websites that says, hey, this certificate is unsigned. It means there's no trust that's linked back to it. So you have to think, remember that with encryption, key management is the Achilles heel. So public key infrastructure is an attempt to provide some level of trust and organization for how those keys are managed and distributed. And there's a lot of moving parts, and yes, it's easy to hack and break. And we need a better way to do that. Okay, moving right along. The best thing to do with a root CA once deployed What's the best thing to do with a root or enterprise CA, according to subject matter experts? once it's deployed. Once you set it up and you implement the public key infrastructure, you take the system offline to prevent unauthorized access. You don't expire or revoke. You don't distribute private keys. If you distribute private keys, all is lost. Private keys have to remain private. If the enterprise CA's private key is distributed, they've been blown. It means that the key they use to sign everything and encrypt everything is in everyone else's hands, along with their public key. Their public key is out there circulating. If you have the private public key pair, you can create your own reality, basically. You can impose as someone else. Any questions?
Okay. I believe I mixed that up with something else from that section. I know there was something that we usually do have expire for security purposes, but I thought that's what it was.
Yes.
I think it
So,
was the keys,
so
encryption keys, or something else.
right, certificates do expire. So when you look at a certificate, if I go up here, I go to the certificate, it's valid from, to, the expiration date is already built in. So the reason that's a bogus answer is because when a certificate is created, the date that it's good for until have already been established. So you don't manually expire a certificate. It expires on its own once that date is reached. Does that make sense?
Yeah.
Okay.
Yeah.
Okay. Now, if you revoke the certificate, you're saying, I don't care if it's still good. I want it gone. So the certificate authority can say, oh, somebody's system was hacked. Their keys are no good. I'm revoking all certificates, whether they're expired or not. So revoking something can happen, but not because of the root CA being set up, right? So you would revoke any previous certificates if a key pair were compromised, you would revoke the certificates. But not because you finished setting up a CA. That's like saying, I'm gonna delete all the DNS records when I finish setting up my DNS server. It's like, okay, why would you do that? So just remember that revoke is like delete. And if you just finish setting it up, why would you delete it? I mean, why would you delete something you've just set up? So I know there's a kind of a different language that we're speaking, but that's one reason why we reconcile and retake these assessments. Okay, that's one reason why we review and go back over the material, because there's a lot of depth to what we encounter in the textbook and then in sessions. Any questions so far? Everybody with me?
Yeah.
Okay.
Not ready for that one.
Web sessions. When you encrypt a web session, basically a random symmetric key is generated for use on both sides of the connection for the session. But it has to be protected somehow. Public key pairs are used to exchange a random symmetric key used to encrypt the session. So we're using a public key to when we receive when the session is initiated, there are random symmetric keys. I'm wondering if that should say private. Anyway, the rest of these answers are just bogus answers. Streaming cipher and block cipher have nothing to do with this. So these two answers by themselves, that's a totally different concept. Symmetric encryption ciphers are either block ciphers or streaming ciphers. That has nothing to do with asymmetric encryption. Asymmetric are two key encryption systems. One's public, one's private. Basically, people have the key pairs. Everybody has public keys. And when you receive, well, so the statement is accurate. Public key pairs are used to exchange a random symmetric key used to encrypt the session. So the session is encrypted by a symmetric key. That's the first piece to understand. To set up the same key on both sides of the session, you have to encrypt them and send them, and then somebody has to use a key to unscramble them, to decrypt them, or you can't use it. And the only way you can do that is to provide the public keys to both parties, who then decrypt the symmetric key. So it's a two-step process, right? You have a session that you're going to set up and you're going to encrypt from end to end. And you're using the symmetric key to do that because it's efficient and it's fast. How do you protect those keys to get them on both sides? You scramble them. You encrypt them using the sender, the key authority, encrypts them using their key, and the people who get them to use them on either side, the server and the client, they use the public keys to prepare them to implement them for the session encryption. Does that make sense?
Yes.
Okay. Okay. After the encryption attributes. So we're talking about EFS. When we talk about the encryption attribute for a file or directory is enabled, here's what we're talking about. Does everybody remember the little demonstration that we did? Here's a test directory. I'm going to put something inside of it. I'll call this secret information, right? When I go to properties and go to the advanced attributes and select encrypt contents, that's the reference we're talking about in the question. In the question, it reads, after the encryption attribute of a file or directory is enabled, it is a best practice to. So what I wanted you to do was to think, okay, after I do this, what's the recommended step to do after that? So if I go apply, it's going to say, hey, you should encrypt the folder that it's in. So I say, okay. And the first time you do that on a system, it prompts you for something. Now, you don't see that here unless you go to details. When you go to details, you can select this and generate a backup key. So the first time we do this, it prompted for this to export the certificate. Everybody remember this?
Yes.
Okay. After you do it the first time on a system, it remembers that you already have an exported certificate. So it's not going to pop up every time you enable. But you can basically do it again by clicking a little further on the details. So if you go to details and then select, and then click backup keys, you can do the same thing that it recommends, creating a backup key that was used to encrypt that folder, right? So let's go back to the question now. It is considered a best practice to secure an offline copy. An offline copy means you don't put it on that system. You don't keep the backup key on the same system with encrypted data or in the same disk. So this is a bogus answer. If you store a copy of the key with the encrypted data, somebody's going to use the key to decrypt the data. It's not secure at all. You've locked something, but you've left the key taped to the lock. Who would use a lock and then tape the key to the lock? No one would do that, right? Delete the key used to encrypt the data to ensure confidentiality. Well, if you do that, you'll ensure confidentiality, all right. No one will ever be able to read it again. It's not a best practice to delete the key you used to encrypt it with, because when you want to read it, you have to use the key to decrypt it. Does that make sense? And I know these are tricky. The wording is tricky, and it's easy to, you really got to watch the scenario, the details in the question for the scenario that's describing. I hope this is helping. Does anyone have any questions at this point? Okay. Effective RBAC is often destroyed when a user engages in peer-to-peer to share media. If you apply inheritance in a granular manner to disable in some cases and enable in other cases, you're actually doing what you're supposed to do for effective RBAC. You're not destroying RBAC, you're actually practicing it. If you assign a user account to a security group for a given role, that's what you do when you're properly implementing RBAC. When you define access rights for a file system object properly, that's what you're doing with effective RBAC. So each of these are things that you do so that RBAC works properly. The question reads, effective RBAC is destroyed when a user does what? Well, if you do this, you undo all the rest. So these are the things you do to work it correctly. And that's why they're not good answer choices, because that's what you do to practice effective RBAC. You're not destroying it, you're reinforcing it. You're practicing it when you do these three things, okay? In your study guide, it says if you do peer-to-peer, you might as well hang it up. Does everybody remember this? Should a user be simply preoccupied with sharing data and media to the extent that peer-to-peer options are enabled without proper review, any benefit of IAM planning and setup is effectively negated. That means it's canceled out. The sole motivation for peer-to-peer connections is sharing, and sharing is anything goes. What you have is everyone else's. What's mine is yours. In a bring your own device work scenario, this can be fatal, quite literally. What do we mean by bring your own device work scenario? Everybody knows what BitTorrent is, right? Let's just take a break to exhale and then let's see here. Oh, I think I deleted this. I had a BitTorrent client. So if you're loading something like a BitTorrent client so you can share bootleg movies and music, that client actually shares other files on your system. There's upstream and downstream traffic. When you're doing bring your own device, that's an acronym that's actually an official term. Some companies are saying, okay, we're not buying your laptop. We're not giving you a desktop to work with. You buy your own tech. When you work for our company, we're not gonna keep replacing your desktop every 3 or 4 years. That's too expensive. We want you to bring your own tablet or bring your own technology or bring your own device. And but it's our data, the data that we use for this business, for your workplace. It belongs to us. But we don't care how you get to it. It's in the cloud. You use your own device. When you're running a bring your own device environment, but somebody loads a peer-to-peer sharing option like Kazaa, Nutella, Bear Share, Napster, BitTorrent, Tor, the Onion Ring, all this dark web stuff. Basically, what you're doing is you're canceling out all the good. Any questions? Okay, I'm going to move faster. And is there anyone that needs to drop right at 4 o'clock? Because I'd like to cover everything.
I can stay a little bit over 4.
Okay, so we have a couple more questions on this end, and then we have these 2 at the top. So we're going to move faster. And I'll post this recording online, okay? And then everybody's going to get the reconciliation done and then retake it right away, yes? Yes? Okay.
Yes.
All right, so it says, except for a user, this is true, false. Except for a user home directory, one must avoid permission access right assignments with user accounts. RBAC best practices allow for this single exception. That is true. You never assign rights with user accounts directly. You only ever use groups, except for the home directory of a user. So what am I talking about? In your solution, each of you had your own named home directory, your first initial and last name, inside the groups, the site directories. You can assign your permissions directly to a user only for that user's directory. Everything else has to be assigned through a security group. That's what that's saying. Any questions? Okay. Like public key encryption. Let's see if we can make it a little bigger here. Like publicly key encryption, for symmetric encryption, the key may be openly distributed without compromising data confidentiality. That's false. Public key encryption is the only one that can openly distribute keys. And it's only the public key that can be circulated. Symmetric encryption has one key, both for encryption and for decryption. If you openly distribute the one key that's used to encrypt, You don't have any confidentiality. Anybody can decrypt it at will. Just remember that symmetric keys have to be protected, and they're often protected by encryption itself. It's kind of a conundrum, isn't it? So I have an encryption key. It's a symmetric encryption key. There's only one that's used both to scramble and descramble, to encode and then decode a plain text message. If I lose that key, I don't have any confidentiality at all. So the trick is to take the key that's used to scramble and unscramble and encrypt it also. It's an encryption of an encryption. It's public. We use public-private keys to protect the one symmetric key. I'm going to say that over and over and over again. It takes a while to get your head around that. That's one reason why people don't do a lot of encryption. On Apple devices, it asks about your keychain. A lot of people are like, what kind of key am I keeping on my Apple device? What's a keychain? Has anyone ever seen the reference for a keychain on your Android phone? Hello? Has anyone seen a reference for a keychain on your Android phone?
I don't have an Android. I have an iPhone.
You have an iPhone. Have you seen a reference to a keychain on your iPhone?
No.
Oh, okay. Well, it's in the privacy settings. It's tied to your iCloud account. So your keychain is stored in the iCloud account. And it's encrypted. And all of those keys, your public keys from other people and websites, they're all stored together on your keychain. Fun fact there. How many of you have Android phones? Is there anyone that has an Android phone?
I do.
Kanisha?
Yeah.
Okay. Anyone else? Wow. Everybody else has Apple?
Yes.
Okay.
Yeah.
Okay. I heard Ray, I thought, or was that Benaya?
Then
Ray, what do you have for a phone? iPhone or Android?
iPhone.
You do?
iPhone.
Wow. Okay. Yeah, my son keeps telling me that Apple phones are very unsecure. I'm like, no, you just don't understand the whole how they do it. All right. Let's talk about random and pseudo-random numbers, and then we'll try to finish up the rest quickly. Select the statement below that accurately reflects how random and or pseudo-random numbers are best used in cryptography. The way to keep this simple is to understand that natural random numbers are ideal. The problem is that there's a very difficult way, it's very difficult to collect natural random numbers. You have to set up equipment, you have to do all sorts of weird things. Computer-generated numbers are actually much easier to create in volume, and you need very large random numbers. The important point is that whether a number is computer-generated using an algorithm so that it's pseudo-random, or it's completely natural and random number in the real world, the randomness and unpredictability factors are the most important. In recent times, computer scientists have figured out how to inject noise or random inputs. So what they'll do is they'll collect like rain, loud rainfall, or crashing waves at the beach, or a rattling fan. So you have a fan that's blowing and it's clankety clankety clank, and there's a loose washer, and it doesn't rattle the same every second. So as you record that, it's generating a random input. That random input when it's used by a computer, will turn pseudo-random numbers into very useful numbers. So that's called a true random number generator. And a true random number generator uses the natural input to enhance randomness and unpredictability that's suitable for use in cryptography. What we've said in all the other answers is basically a bogus answer. True random number generators do not use only coding algorithms. When computer scientists used only algorithms, they weren't truly random. There was a pattern to them, and they weren't as random as they needed to be, and they were predictable based on the algorithm. Meaning you could crack it. If you use cryptanalysis, you could break the code. Artificial computer algorithms alone can generate pseudorandom numbers suitable for use with the most sensitive. It's this word alone. So the word only is a problem. I should probably highlight that and underline it. Highlight this and underline it. If a computer algorithm alone generates pseudorandom numbers, it's not suitable for use with most sensitive data. If it's sensitive data or top secret data, and you're only using algorithms, the best you're going to get are fake random numbers, or pseudo. The word pseudo means fake. So if you're using computer algorithms alone, you're basically saying the same thing as this, you're just restating it. It has been verified that no computer algorithms are suitable. Nobody selected that item. I'm glad you didn't. Yeah, we do have computer algorithms that work, but they use a natural input. Any questions? Workgroup security account management differs from enterprise or domain SAM because a local SAM exists on each system in the workgroup. A domain uses a consolidated SAM. That means it uses a centralized or domain SAM. A consolidated SAM is a centralized, it's a single security account management database, and it's stored on domain controllers. So the word consolidated means enterprise or centralized. This business about privileges are assigned to file system objects instead of security groups, and privileges are assigned to security groups and permissions. So in your study guide, it talks about how permissions are access rights that are assigned to file system objects. Privileges have to do with the placement of accounts in security groups. It's accounts assigned to security groups, not file system objects. So permissions have to do with file system objects. Privileges have to do with security groups. And why isn't this a correct answer? This is stated verbatim as true in your study guide. It just has nothing to do with what's different between enterprise and workgroup. This has to do with like file system permissions and privileges, but it has nothing to do with the accounts and where they're stored. So even though this answer is correct, it doesn't have anything to do with the differences between workgroup SAM and enterprise SAM. Does that make sense? Here it says a workgroup SAM exists in one central location. No, that's a domain or enterprise SAM. A domain uses a SAM on each system. Well, that would be chaos. If a domain environment stored a separate account management database on every system, then all you'd have to do is hack one system and everybody would be gone. Everybody would be compromised. So, any questions about that item? Okay, last one here, and then we jump up to the last two here. So we have 3 left. Deep breath, almost there. Okay, it says encryption may include identity account component. components. So if authentication factors are weakly implemented, this may degrade effective encryption. This is stated in your study guide. We tell you that or ignore. So this has to do with the type of SAM or ignore two-factor authentication. So there's a couple of ways that encryption, basically you can blow up encryption. The important thing to remember is that identity is a linchpin. Everybody needs to use two-factor authentication. Everybody. Two-factor authentication. Your identity is used to create components of encryption systems. So if your identity isn't strongly protected, your encryption isn't going to be very good either. Does that make sense? I thought we kind of stressed that in class. I hope you remember that. Okay, multi-answer question. Which are common habits of users that undermine the most common data security measures? The most common data security measures are what? What are the three most common security measures?
The two-factor authentication and
Identity management is one
yeah.
with two-factor authentication. Yep. RBAC. And what's the third one? Encryption.
Yeah, the encryption.
Two-factor authentication, RBAC, and encryption. So users often fail to think about the intended use and users of the data that they create. That's the biggest problem. Nobody really, you have a device, you're creating data, you're going to share it with other people. How many other people? We just don't think about it, right? You have an iPhone. Do you go into your iPhone and turn off AirDrop? If you don't, you're not giving any deliberate thought to the intended use of the data that's created on your iPhone. All but one of us own iPhones. If you don't go in there and turn off AirDrop, you're not giving any thought to what happens with the data that's on that iPhone. You're basically saying that anybody that is in proximity, if we're in the same room, it used to be the default was AirDrop was enabled. If you had anything on your phone that you shared with anyone at your house, the moment you walk into the room with me, now it's an AirDrop and I see it, right? It's a big problem. They don't set up two-factor authentication methods even when readily available. That's the other thing. So those are the two linchpins, right? It's like of all the things that users do that undermine most of the common data measures, especially in bring your own device environments. People say, it's my personal thing, it's my business, get out of my Kool-Aid. I don't tell you what to do with your device. You don't get to tell me what to do with my phone. This is my tablet. This is mine. This is my laptop. I'm going to do with my laptop what I want to do with my laptop. You don't get to, you're the boss of me, but you're not the boss of my laptop. I own the laptop. This is not your laptop. This is not your personal laptop. You don't get to say what I get to do with my personal laptop. We have this natural mental barrier. And we just think that as long as it's physically in our possession, it's okay. And what most people don't realize is that everything's interconnected now, and it's not okay if you don't think about the use and the users, okay? So anyway, any questions about this item? Let's look at this answer. Configure the first account for a new system with elevated privileges. Why is this not a good answer choice? Let's read the question. users often fail. Do they fail to configure a first account with elevated privilege? No, everybody does that automatically. Users don't fail to do that. They do it without even thinking about it. They
How come it's
succeed.
natural, right?
Yeah, it's the wording, right? It's the wording. Users succeed at configuring the first account with elevated privileges. We all do. When you get a new system, the first account, you set it up, you have just succeeded at configuring the first account of a system with elevated privileges. We all do that intentionally. We don't fail at it. We absolutely excel at it. The problem is that we go on using that first account for every routine privilege, every routine purpose. So when we get out on the internet where we're exposed, we're still on that privileged account. That's the problem. What we fail to do is to refrain from using the first account with elevated privileges for web and email. You will see this on your cumulative exam. Users fail to refrain from using the first account with elevated privileges for email and web where they're most exposed. Does that make sense? How about this one? Include access rights for users and everyone. Users don't fail to do that. It's automatic. When a user sets up a share, users and everyone is included automatically. Users don't fail to do that. It's automatically done for them. That's a big problem when you think about it. I'm sorry that the wording is so tricky, but one thing you need to understand, that's part of the business we're in. System security is about tricky wording and tricky details. When you connect to a new network, everybody see my screen? When I connect to a new network, it's going to ask me, hey, wouldn't you like other devices, connected devices to find your system? And the default is already highlighted for you. If you just click through that, you're answering yes. That's what happens. Okay, last question. It's the ordering question. What are the 4 tasks for RBAC in order? The first task is to create directories with matching security groups designed for a given role. Now, I created the security groups for you in the domain, but then you created the directories that match those security groups. For your solution, that's the first thing you had to do. And you see, most everybody got this right. The second thing you have to do, you set the file level rights with security groups and enforce using inheritance. So you're working with inheritance and you're assigning to security groups, except for the home directories, right? That's the second thing you do. Any questions so far? Then you hide the network shares. So you create a network share, but you hide it. That's the first thing you do. If you don't put a $sign there, shame on you, right? And then you configure the rights that match those NTFS permissions. So you're going to create network share permissions that match the file level permissions. Any questions about number 3? And what's the last thing you do? You want to apply custom login scripts for seamless access that ends when someone logs out. Persistent equals no. That's the last step. Any questions about the ordering? Okay. Would anyone like to stick around for assistance with the solution or with other things before we close? Does everybody know that we need to get the reconciliation done quickly? Everybody's going to do this as soon as possible, right?
Yeah.
Okay.
Yeah.
Okay. Well, it's fresh. And then we'll do the retake for module 1 and module 2. And then we'll meet briefly on Friday at 3 o'clock. And then I'm going to post the midterm. When I put the cumulative exam out, all of these things are going to be hidden. So you won't see module 1, you won't see module 2, you'll just see the midterm exam. And you'll have to have that done by the time we start on Monday of next week at 3 p.m. So your exam has to be done. It's a 90-minute exam. It will cover what we did for module 1 assessment and for the module 2 assessment. Okay? Okay. Unless you'd like to stick around for additional assistance, that concludes our class for the day. I'm going to stop sharing and stop recording.